Applications of differentiation. This is a rates of change question involving speed, distance, and time. A body moves in a straight line, so its distance, s in meters, from a fixed point after t seconds is given by this cubic equation. We've been asked, firstly, to find its speed after 2 seconds. I'm going to use the letter v for speed here. V, the speed or velocity, is the rate of change of position with respect to time. In other words, ds dt. So if we differentiate the function with respect to time, we get the speed. So we differentiate by multiplying by the power and reducing the power by 1, giving 27 minus 3t squared. So this is the velocity. After 2 seconds, what would this be? This means instead of t, we're going to sub in 2, giving us that the velocity is 27 minus 3 times 2 squared. Now 2 squared is 4, 3 fours are 12, 12 and 27 is 15, so 15 meters per second would be the velocity after 2 seconds. The next question is, after how many seconds is the body at rest? In other words, what's the time when the velocity equals 0? That's what at rest means. The speed or velocity is 0. So that means 27 minus 3t squared is equal to 0. So this is a quadratic. If we take 3t squared from both sides, divide both sides by 3, we see 9 is t squared, so t is equal to 3 seconds. So that's the value that we could sub in into our velocity and we will get a 0 output. The last question is about the acceleration. Acceleration is rate of change of velocity with respect to t. dv dt is the second derivative of the distance function. So we differentiate 27 minus 3t squared, giving negative 6t. So this is the function that expresses the acceleration. Now when t is equal to 2, that acceleration would be negative 6 times 2, which is negative 12 meters per second squared. And the units are important here as well.